Super happy to have you all join us. My name's Fran. I'm a solution architect at Sigma Computing. This is Richie Caputo. He's a joint customer of Sigma and Databricks. For those of you who haven't heard of Sigma before, Sigma is a BI intelligence platform that sits directly on top of Databricks, giving you a view of all of not just the data and the resources that you have in the Databricks data catalog, but also all of their advanced AI functionality and data science functionality. And in today's talk, Richie's going to share some of the amazing things that he's built in Databricks and then been able to work with, surface, manipulate, and kind of expose to his users through Sigma. So with that, really excited to give the screen over to Richie.
Awesome. Thank you so much, Fran. All right, so quick introduction on TJC. We're a middle market private equity firm. We primarily invest in the industrial sector, technology sector, healthcare sector, and supply chain and logistics. And we deal primarily with unstructured data, right? We're talking PDFs, Excel documents, the occasional Word or PowerPoint. And innately, these files are very useful. They contain a lot of data that our investment team and our investor relations team and our business development team, they consume on a daily basis. But it's very hard to deal with these in a dashboard setting. We don't necessarily have an easy way to extract metrics by hand out of these files. So we're looking to Databricks and Sigma to deliver better decision-making, enhanced portfolio management, and advanced analytics. But to get there, what we're going to be discussing today is unstructured schema generation, or what we call USG. And largely, this just stands on the LLM technology, right? The LLM infrastructure. We can now prompt out structure from unstructured data. So to give a flavor for unstructured prompting or unstructured schema generation, we have to talk about structured prompting. So typically, we're trying to make JSON out of an LLM. This is a very useful structure. I can turn this into a struct type in my Spark schema. This is basically serializable as a delta table column. But what's the issue with this, right? Like this model by default is going to produce some triple bracket JSON output, but there's no guarantee that that's going to be serializable. So what we've done is we've moved over to a package called Unstructured. And Unstructured is a package written by a person named Jason Leo. And he has a video on YouTube I highly recommend called Pydantic is All You Need. And he went ahead and built a library that has a lot of open source maintainers that produces Pydantic objects from LLM calls. So why is this useful, right? At face value, it's kind of hard to tell the difference between these two responses. In this response here, we're actually using function calls under the hood. So you're guaranteed to get a Pydantic object back or the call is going to fail. So in this case here, we don't have to do any other structured prompting. We don't have to tell it what the age schema is. We don't have to tell it that name is a string. The Pydantic object actually gets passed as a prompt to the object's system instructions. And that's what helps it produce that structure innately. Of course, with Pydantic, you can do a lot more than just this, but this is kind of a format to give you the idea. So how it works, it's very straightforward. We just have to call instructor.from OpenAI on the OpenAI client. And the rest is history. We just have to pass a response model. And what we end up getting back is that response model actually type hinted in the IDE. So for us, typically, we're going to be writing this in a library that we end up importing into Databricks. It just makes testing a little bit easier. But for those of you who are familiar with Pydantic, there's a lot you can do with this object. You can actually add validators to make sure that, let's say, the age is between a certain threshold. You could put a character limit on the name. So there's a lot of governance you can have in this Pydantic call. But why Databricks, right? Like none of what we've done thus far is unique to Databricks. Well, the issue is, if we're dealing with tens of thousands of documents, we need to run this in parallel, and that's going to be pretty hard without something like Spark. And furthermore, I don't want to just store a Pydantic object. I want to store a Spark schema. So how do I do that natively, and how do I reduce the amount of boilerplate code? One other thing I wanted to add is we've actually wrapped Databricks logic here. So Databricks has been really good about adopting the OpenAI kind of API templating. So we can actually pass our Databricks host and Databricks token to serving endpoints. And you'll notice here that we have to pass a special mode called MD-JSON. This may change after some of the announcements we heard this morning on function calls. But a couple weeks ago, function calls were not supported by Databricks models, so we had to kind of rework this a little bit. But this does work, right? I can run DBRX on this. I can run Llama 3 7DB hosted internally. So if there are privacy concerns, if you don't want to be using OpenAI for your calls, you can definitely use your self-hosted models here. All right. So back to the original point. How do we do this in Spark? There's some really useful links between Spark and Pydantic. So two packages I've referenced here: Pydantic Spark, which we use, or Spark Dantic, which I think we're probably going to move to. It's just a little bit better maintained and just kind of more active. But both of these packages do kind of the same thing. They take a Pydantic object and they make it serializable into Spark schema. So in the case of Pydantic Spark, which we use, we just have to export that Spark schema. And then we have a JSON object that translates directly to something I can use in a UDF. So this really simplifies things. I don't have to write an entire schema for my UDF. I just have to write one Pydantic object, and I can create a UDF that, in my call to this model, I've produced an entire struct. And these can get really complicated. I mean, you can have full object inheritance models. You can have really, really nested deep classes, and this will work perfectly fine. So in our case, this is just a graphical of the workflow. So we get a raw document. We'll typically store these in an Azure blob, and we'll mount that to a volume. For text extraction, we're using a service called Tika, which maybe some of you in the audience have heard of. Tika is an Apache library written in Java, and it's basically designed to extract text from pretty much anything. So in our case, because we have so many different file types, this works really, really well for us. And in fact, we use a Databricks Labs library called Tika OCR. Happy to talk offline in more detail about that, but that's something we've contributed to. It's actually extracting text in the JVM and in your Spark worker. So you can do it now in parallel within Databricks. It functions very similar to the binary files format. And then we do our work with the LLM. So we pass an LLM call, usually to a text blob in the document. I think this works best when you have 10 pages or less of document content, because then, right, you can just pass that entirely into the model, and you can get the entire document summarized in the schema that you want. There are ways to deal with larger documents, but then you need to do some type of RAG or something to deal with the context as an intermediate step here. And then, yeah, we create our Pydantic object, we turn it into a Spark object, and now we can actually stream these results. And you can imagine why streaming is really important in this setting, right? Each of these calls is expensive. And I really only want to do them once unless I have to, unless I want to recreate that schema. Let's say the LLM may be messed up or I wanted to tweak something. Maybe I'll do that for 1% of my entries. But for 99% of them, I'm going to be pretty happy with the results. And I really only want to do that once. So streaming in this case is extremely important. And yeah, so why is this beneficial for us? So like I said before, we deal primarily with PDF documents, Excel documents, so things that aren't native to Spark's ingestion services. Even our Excel files, they're not really tabular in nature. So what we do is we kind of treat them as these unstructured blobs, and we try to build very abstract data models on the LLM Pydantic side. So that's worked really, really well for us. And I think what's crucial for us too is the ability to go from large models to smaller models. So GPT-4o and Claude 3 Opus, these models we've had great success with just zero shot. We just pass the entire document, we pass the Pydantic object, and you get back what you're looking for pretty accurately. I mean, these models are just smart enough to kind of understand what you're looking for, but they're expensive and they're slow. So what they can do a really good job of is with this library, create schema'd training samples that you can then fine tune on a DBRX, a Llama 3, or a 3.5 Turbo. So this is kind of the approach we're taking. Once we hit about 1,000 or so samples, we usually find that fine tuning on that, you can get the model to pretty much memorize that JSON schema. And then you save a bunch of tokens too, because then you don't have to pass that Pydantic schema instruction to the system message. This all around has been transformative for us. And really the goal of this is to leverage tools like Sigma so that we can actually dashboard for our non-technical users. So this is just a quick example for a live use case that we have. We're not doing a live demo, but this is an actual live use case where we're summarizing cap tables. These are basically agreements that define ownership in a company. But you can see here, right, we're really just concerned with a subset of these fields. And we can do some cool things, like we can check that the sum of the tranche percentages sums to 0 or close enough, with float rounding. But you can also specify date time objects. So you can specify the date of object as a date of grant, as a date. And that'll actually render on the Spark side as a date. And then similar for share class, right? We can actually define literals. So the model's guaranteed to respond as A or B, or the validation of the Pydantic object's gonna fail. And this is what we're able to get out of this in Sigma. So everything you see here is AI generated. Of course, we had to censor some of the labels just for privacy reasons, but everything here is AI generated for a POC we did for our tax team. And what's great about this use case is this is generated with DBRX, so fully private. We can pass PID into that model because we're hosting it. And this is 100% accurate in this case. So the model performed very well. Admittedly, this is maybe a simpler problem than what we typically do in terms of the depth of the structure. But this gives us immediate value. We can actually plot things now. I can render things as numerical objects. I mean, it seems trivial, but for us, this is really hard, right? We don't have this native to anything in our ecosystem, so we have to kind of build it from scratch. So this has been transformative for us, and all our non-technical users can now go in here. They don't have to be aware of the LLM behind the scenes doing all this complex stuff. They just get to see the nice results.
I'll hop in here as well.
Please.
Like what I really like about this process is it's really the conversion of an unstructured set of information to a structured set of information. And when we make something structured, not only do we make it easier to analyze and aggregate, we also make it much more accessible to users who don't know how to parse through things with code. They don't know how to run LLMs themselves. So turning what, in this case, each one of these rows kind of represents a full unstructured document. We've turned that row now into the 8 or 9 key variables that are relevant to the user. It turns something that's literally inaccessible, not just in content, but also in skill. It makes that accessible to the entire suite of, in your case, tax reviewers. And I really like that process here.
Absolutely. And to build on this even further, this is, I think, where we start to extract maximum value from Sigma. So the ability for Sigma to call warehouse functions allows us to run LLMs as a column. So this is a kind of a turbocharged version of what we've built thus far. If a user wants to come in and ask a little bit more of a specific question, let's say, what's the definition of IRR in this document? That may change. These documents may explicitly define IRR. And then right here, you can see that because we're passing the entirety of the content text, these are like 7-page documents, give or take, it's able to have full context as to what the question is, and it's able to basically find that exact definition here. So this is something that we're really excited about with Sigma. You can imagine doing far more complicated versions of this. Like you can embed a RAG system in here. Anything that's servable from your Databricks endpoints, you can call it right here. And of course, like, if you don't want to be using AI, that's completely fine too. You can write custom functions that do, let's say, a very specific workflow that you're interested in. But this has been absolutely huge for us, especially the ability to do this on thousands of documents pretty much in parallel. So our users are very, very happy with the ability to ask kind of questions at scale without really having to do a lot of hard work.
Mm-hmm. Yeah, and what I like about Richie's flow here as well is on this previous slide, right? We are seeing in these columns more governed output of an AI model, right? These are things that your LLM engineers are basically specifying. This is the information we want to pull from the text. This is something you always want your end state consumers to see. But this kind of gives, or what Sigma's custom formula here lets you do is say, well, what if as a data engineer, you didn't answer every question your end user would have? Now your end user can add new formulas in this manner and ask new questions of the text. So I know that you have a resume parsing use case, and there'll be this dynamic need to say, listen, we've trained the model very well to capture these fields, but maybe for a new position, all of a sudden we need to think, do they have this coding experience? We could bring that into this kind of dynamic question and ask something that maybe wasn't pre-architected in the first place. So we can serve both the pre-processing and the post-processing ad hoc questions.
Yeah, absolutely. And with input tables, I think what we're going to move toward, and we've talked about this a lot internally, but we can aggregate, let's say, 20 to 50 user questions, and we can make that interaction very dynamic. So a user can go into Sigma. It doesn't matter what team they're on. They don't have to be a developer, and they can, let's say, update a list of template questions as an input table. That input table, because it gets written back to Databricks via a warehouse connection, that's then usable in your production code. So this workflow has really helped us get our non-technical users kind of behind the scenes and allow them to modify things that are in production. Of course, there is governance there, right? You don't want to just let non-technical users change everything. But if you turn your problem into more of a data as code problem, it's safer and easier to get those users in the loop here. So on that point, that template of questions we can then use to automate, let's say, answering questions for a data room that we get for a potential deal. So, questions that are very repetitive that our investment team asks on every single deal, we could try to attempt to answer all of those in parallel using the input tables architecture. I think we have a couple more slides here. So there are definitely some limitations to this workflow. It's definitely something that's pretty new. So with shared clusters in Databricks, UDFs are a little wonky. I haven't been able to get them. To work very, very well. So that means serverless isn't really an option yet. At least on the UDF side. If you want to do this one-off, if you want to call it in a cell, that's perfectly fine. We're still working out the kinks there. I'm sure that in a couple months that'll be doable. It's just kind of one of those things. Serverless is a new product, so it's not fully optimized yet. And then when you're partitioning your tables, usually the way we've done this at least is we're passing a AI UDF on top of a column of text. And the way that Spark partitions tables is based off of kind of big data. I think it's something like 256 megabyte chunks. That's way too much data per partition for this use case. So there's a little bit of config you need to do in the Spark configuration. But typically we just try to repartition on like the number of rows, or maybe like 10 rows per partition. So that gets you pretty good performance, because then each core is getting allocated to a single LLM call. So that's where Databricks really makes this LLM call infrastructure much, much more performant and much more scalable. I said this already, but documents that are large really need some type of intermediate processing for this to work at scale. Obviously, modern models are very capable of very long context. Databricks DBRX is 32K, and GPT-4o and Claude 3 models are 128K or more. I think Claude's even 200K. So they can handle that amount of context. It's just that if you're doing this on millions of documents and you're allowing all that context to flow through, you're going to have a cost blow up, right? Like you're going to be parsing a lot of stuff you don't need. So there is more to do in this section, especially for us. We haven't really explored as much as we'd like to into that area, but some type of pre-processing step to compress that context is going to save you a lot of time and a lot of money. I think this one might be actually the biggest for us, is failures in the Spark pipeline. So you have to be very good at exception handling in your UDF. At any point, if let's say you're parsing a partition of your data, if that UDF fails, and these LLM infrastructures can fail, right? They're random in nature, so maybe you try to rebuild your Pydantic object too many times and you hit a failure that way. You're going to lose all that work. So you have to be very careful. So we try to log JSON output from the Pydantic model. We also try to do kind of smaller batches so that we can kind of run through the model. So balancing those things, right? You want to be parallel, but you also want to make sure that in the case of failure, are you handling that gracefully? And then finally, I don't want to bash on LangChain too much, but LangChain, some people love it, some people hate it. We find personally that it's a little overdeveloped and it can be a little cumbersome to use. So we try to avoid it, but that is an alternative to this. They're supporting Pydantic serializers, and these are models that you can actually productionalize via Databricks. But we've had a lot of trouble, right? The Pydantic serialization is not great. So I hope it gets better, but I'd love to see Databricks kind of move more into this arena where they're making models that produce actual Spark schema. And yeah, I think that's pretty much it. I think we have some links in here if you want to check out the libraries we're using. But otherwise, Thank you very much.
Thanks so much. Nice.
Awesome.